What's good, everybody? This is Cream Spinach Joe, and this is another episode of Math, Science, and Modern Warfare 3. And in the previous two episodes, we talked about two organic chemistry reactions. In this episode, we will be talking about the third organic reaction. Now, in the first videos, we looked at the nucleophilic substitution reactions, hence the name SN1 and SN2. Now we're going to look at the reaction called the E2 reaction. Now, the E2 reaction, the E stands for elimination. So what you're going to see is you're going to see the elimination of either some type of, you got a bromine or some type of chlorine. So that's where the name comes from. Now, it's done. There are ways to determine between the S and N reactions and the E reactions. I will not go into those. However, simply by looking at the mechanism, hopefully you'll be able to see the way the charges are laid out, what makes them different, and how you can tell which one to favor over another. So let's begin. Now, we're going to be talking about the E2 reaction today, and the reason why we're not starting with the E1 reaction is because, again, like the SN reactions, I feel that teaching the E2 reaction first provides a much easier, it just provides a good foundation for teaching the E1 reaction. I feel that it's a little less complex, and I feel that it's really, it's quite, once those electrons start moving, the train just keeps going, and really what you get with the product is what you get. So let's look at our mechanism when we have, when we were dealing with ethoxide ions. Now, in this first picture, which you're seeing now, you see that the C2H5 with the O- on it, that's the basic ethoxide ion, and will attach to, it has a negative charge, right? Hydrogen has a positive charge. So the basic ethoxide ion begins to remove a proton from the beta carbon, using its electron pair to form a bond with it. Now, when we say beta carbon, that's not a special type of carbon. As you see in the picture, the alpha carbon and the beta carbon is simply to distinguish between the two carbons. It's like naming them carbon 1 and carbon 2. There again, if in the more complex, there is, you can talk about alpha elimination and beta elimination and stuff like that. We're not going to be focusing on that. We're just going to talk about alpha and beta as simply a device used to give these carbons a name. So, so the ethoxide forms a bond with that beta carbon, and then at the same time, the electron pair from the beta carbon-hydrogen bond, right, begins to move in to form the pi bond of a double bond, right? And you'll see that in the next picture. But basically, a pi bond is what we call is a reference when you talk about the electron clouds and the bonding of it. It's a pi. For single bonds, it's called sigma. Again, that's another video because that can be quite complex. So to continue, the bond moves in and it starts forming that double bond, and then the bromine, right, because the electrons are moving from the hydrogen-carbon bond to the carbon-carbon bond, and the carbon-carbon bond to the carbon-bromine bond, right? So like I said, the train just keeps moving. The electrons just keep moving down the line. And so because of this, the bromine begins to depart with the electrons that bonded to it, the alpha carbon, right? So you can see that it's kind of, you can already see the elimination starting to happen. Now, in this next picture, here is the second step, right? Here's our transition state. Again, noting the transition state with that double dagger, you can see that, in the midst of this, you can see kind of the partial bonds being formed and our partial and negative charges, right? So you can see how these electrons are forming, and you can see how this is starting to move, right? You can see that the OH, that's going to bond. The electrons from the HC bond will move to the double bond in the middle, so the hydrogen will probably break off. And then along the similar logic, the electrons from the carbon-bromine bond are moving to the bromine, so guess what? The bromine's probably going to break off, right? And so the partial bonds in the transition state extend from the oxygen atom that is removing the beta hydrogen, right? Remember, that's just the naming. Through the carbon skeleton of the developing double bond to the departing leaving group, right? In this case, the bromine is the leaving group. The flow of the electron density is from the base towards the leaving group, and as an electron pair fills the pi bonding orbital of the alkene, right? And this is basically the fancy way of saying exactly what I just said. Now, let's look at this final and third picture in this reaction, right? It's pretty simple, right? If you paid attention to the previous step with the transition state, basically what I just explained is what you get here. So at the completion of this reaction, of this E2 reaction, the double bond is fully formed and has the alkene has a trigonal planar geometry at each carbon atom, right? That just means the electrons are not at an angle; they're at a 180 degree angle along that plane, right? And it looks like a triangle, right? Because there's the C and then there's the two things sticking out of it. The other products are the molecule of ethanol and the bromide ion, right? And that's pretty much the reaction. You can see if you really focus on the transition state, you can see how the electrons just kind of pop everything off. Now, and that's it, right? And you can see the elimination right now, right? You can see that. In this case, we started with that alkene, and that had a hydrogen and a bromine on it. We put it with that ethoxide ion, and we got rid of that hydrogen and that bromine. And in doing that, we did form something of a little more stability with that molecule. So that's pretty much it for this reaction. Now, if you are kind of curious, if you talk about the Gibbs free energy of this, there's only one transition state, but the beginning step to the end step, you actually decrease energy, right? So heat is given out by this reaction. There's a bit more, just trying to go a little more deeper for you guys, just like Inception, right? Going deeper. And that pretty much does it. So you can see how the E2 reaction works. And now that's about it for this video. Once again, thank you for watching. I hope I explained this well. Feel free to subscribe to the channel and like the video. And as always, you can follow me on Twitter at CreamSpinachYo. And well, I guess that would be it. Have a great day. And once again, thank you for watching.